Welcome to the second video on C programming. The previous video dealt with the basics of C programming. Basics in terms of introduction, history, and requirements. In this particular video, we will study about the structures of a code, the way a code is structured, and the desirable characteristics of a code. Not only these two aspects of C programming will be learned, but also how to run a program in different IDEs. The IDEs include Turbo C++, code blocks, and GCC compilers, and how to compile the program in these three IDEs we are going to see. So let's begin. So the very first part of our video comprises of the structure of a program. Now what is the structure of a program? Structure of a program means the way the program is designed. The way the program is written. These are no strict rules, but it is desirable to follow these rules because the errors are minimum if you follow the structure of a code. Now the structure which has been mentioned here, the four parts of the structure are almost the same in every language with some minor changes, but we will stick to this structure throughout the entire course. Wherever we will deviate from this particular structure, we will mention. So what is the structure? The first part comprises of the header files. Header files or classes. Now what are header files? Header files are files which have a .h extension. What is .h extension? We all know that a Word file, MS Word file, ends with .dox extension, and header files end with a .h extension. So it is the extension. Now what does the header files contain? Header files contain some of the basic operations. We include those header files in our program and we call those programs which are present in the header files to make our program more readable. Not only readable, to make writing of the program hassle-free and to increase the readability of the code. The next part consists of function prototypes. Now what are functions will be discussed later on. From now on, functions are subroutines of a program. We will discuss it later on in the following videos, but the concept of function is very important, but we will not know it now. But this is the second part of the structure of a program, so it is to be understood, not understood, the term should be familiar with you. The third part consists of the main function. Now the most important part of a program is the main function. Without any main function, a program will never run. Alright, a program will never run without a main function. So whenever you write a program, irrespective of any functions you use, always write a main function, because main function is actually the controller of the entire program. It controls the flow of the program. It controls the way the program will run, when what subroutine will be called and what will it do with its data, etc., etc. These are maintained by the main function. Now the fourth part consists of the functions should be written. It is mentioned like that. So what are these functions should be written? Actually, in part 2 we have defined some of the function prototypes, right? We have defined the prototype of the functions before the main function. Now those functions will have to do some work Now those functions will be doing is instructed after the main function. You can of course do it before the main function, no issues with it, but try to do it after main function because it is the convention, and it is desirable if you don't break the convention. So this is the structure of a program. Sometimes, there are minor changes, as I said earlier, which will be discussed whenever those changes occur. Now, the next part, we will write our first C program. What is the first C program? We all know it is to print hello world. Now, not only we will print the text hello world, but also we will see how it works and how the program processes itself. Though this is not everything about the C programming, this is just the most basic program. Alright, if you can write hello world, don't think that you know everything about C program, because C program is a huge area and you know nothing about coding at all. Alright, so we'll just show you how to write a program, how does a program look, etc, etc. Hello world program never teaches you how to write a program. It shows you how the program works and what a program looks like. So let's proceed. Now, I told you about three editors. One is the code blocks, another one is Turbo C++, and another one is GNU GCC compiler, or the compiler that is used in Linux, which is the purest form of compilers, the Linux one. So how to compile a code in code blocks, we will see it. Let us see. What happens here is we have to open a new source file. Alright, I'm sorry, not a source file. You have to open a new file. You have to write the program. You have to save the program. You have to build the code. You can see that the build option is there on the tab above. It looks like a yellow symbol, yellow setting symbol. We will see it when we do it. Then we have to run the program. Run option is also on the top tab, and it looks like a play button in green. The next compiler is Turbo C++. Compiling a code in Turbo C++ is quite easy. Just have to open a file, but write the program, and to run the code you have to press Ctrl F9. Now, though the compiling and the working in Turbo C++ is easy, but Turbo C++ has some difficulties. Alright, we will see when we will run the program, then we will understand what are the difficulties. For that, Turbo C++ allows some external features to avoid those problems. We'll also see those external features. And the third compiler is the GNU GCC compiler, which is found in the Linux environment. Now, running a code is a bit difficult out here. Not difficult, a bit tricky. First, you have to open the file in a VI editor. Right, VI editor. We'll talk about it in videos where we will describe the Linux environment and how to work with it. There we will come across the term VI editor, and you have to press I to get into insert mode. Right, you have to write the code or the program, then you will press escape and then :WQ. Once you press :WQ, the program will be saved and you will go back to the command mode. Okay, we all know that Linux is a command based operating system. There are of course some distros, some GUI distros, but we will use the command form because it is more favorable in these cases. And after that, we will write the command gcc filename.c. What gcc does is gcc compiles the code Which code will it compile? The code named filename.c. Alright, next what we will do to run the code, you have to press dot front slash a.out and press enter. You will get the output. So let us see how it occurs. First we will see it in code blocks. I have the code blocks turned on over here. You can get the code blocks installation file from internet. Now see, the first part was to open a new file. I opened a new file, an empty class. Okay, now what I'm going to do is, first part of a program consists of a header file. I'll include the header file. To include a header file, you have to use the keyword include. After that, within the angle brackets, you have to mention the name of the header file that you want to include. In this case, I want to include the stdio.h header file. What is stdio.h? stdio.h is the standard input output header file. What it does is it takes input from the standard input devices and gives output in the standard output devices. The standard input device includes the keyboard and the output device includes the monitor. Okay, next we have to define the before that, we don't need any other header files in this particular program to write to print hello world. Next, what we are going to do, we have to define the functions. Function prototypes need to be defined, but in this particular case we don't need to define any particular functions. Main function is enough to run the code. So we will write the main function. Now try to write the main function in this form. Now what are these will be discussed later when we go into functions and data types, when we will learn about function and data types, why int and why main and why void, etc, etc. You open the brace and you close the brace, and within this block, this is called a block. Starting from here, ending here, this is known as a block. Within this block, you will print the message hello world. So how to print? The instruction that needs to be given to print a message is printf, and within brackets and within quotations you need to give the message hello world. Okay, and then you need to return 0. Now why return 0, why int main void, these will be discussed when you will learn functions, so please keep patience. Until now, just understand this part. Printf hello world, what it does is it instructs the compiler or instructs the computer to print the message within the quotations. What is the message within the quotations? It is hello world. Okay, now let us compile the code, but before compiling we need to save the code. How to save the code? File tab, save file. You can also press Ctrl S. So let's save the file. We will save the file by name hello, and we will save it. And to build the code, you have to press this button. This is the build. So build means compile, see if there is an error or not. So we press this button, and here if you get this message, build finished, 0 errors and 0 warnings, that means your code is completely fine, there is no error in it. Okay, so this is the message. So my program is correct. Now I need to see the output. What is the output? So to see the output, you need to press this button. Now keep one thing, observe one thing, the time that it takes to print this message. You can see it takes a lot of time, isn't it, to just print a message hello world. So that is what makes the difference between Windows environment C compiler and a GCC compiler. Anyways, so we have done with we have learned how to write a program in code blocks and how to compile it and how to run it. Okay, so I hope you will be able to run the program in code blocks. So let's close it. Our next one was the Turbo C++. The Turbo C++ is also open here. Alright, so let's see. What were the steps of Turbo C++? The steps of Turbo C++. Sorry for this, I cannot maximize this screen. It doesn't allow to do because of some resolution problems because I'm recording the screen. Anyways, let's get back. So what was our first part? We need to include the header file. So hash include within the angle brackets stdio.h. No need to define any function prototypes. So let's directly go to main function and then let us print the message printf. Let's print something different over here. Let's not print hello world. Let's print I love programming. Okay, I love programming. This is the message that we want to print, and after that we want to return some value 0. As I said that these things will be understood when you understand the chapter of functions, which will be discussed later on. Now one more thing that you should observe, that here we haven't given any parameter. In the earlier program I had used void, so it doesn't make any sense. If it is void, void means what? There is nothing. So if you don't mention anything or if you write void, it makes the same meaning, so it will not hamper. But if there was any other data type like int over here, if it was placed inside here, then it would have to be mentioned, otherwise it would be treated as void. Okay, so our program is done. So let's run it, and first we will have to compile and then we have to run. So to compile the code we use Alt F9, to run the code we use Control F9. But if you use only Control F9, the program will be directly compiled and then run. Alright, so I'm directly using Control F9. Where is the output? Where is the output? So this is the problem with Turbo C++. To see the output, you have to go to the Window tab. Okay, then you have to press the Output tab and see I love programming. It has been given here. Then again you have to go to the Window tab. You have to close the tab and then it will go. So how to resolve this problem? So the creators of Turbo C++ have given one more header file which is known as conio.h. This is exclusively present in Turbo C++, not in any other compilers. You will get it in you can use this one in code blocks, but avoid using it because this is not a predefined header file of C. It has been created for these problems which we face in while using Turbo C++. So here we will have to do a bit of editing. We have to give this message instruction get ch. Get ch is a function which is found in conio header file. Now if I press Ctrl F9, my output is given. Now there is a problem. You can see that the two messages are given, I love programming and I love programming. Why does it happen? It happens only because the previous program when it had ran, that message is not being cleared. That message is still there and again it is running. So if you again compile the code, you will find 3 messages like that. The previous 2 are retained and one more have been printed. So how to solve this problem? they have given one more function, the clear screen function, CLR SCR function. It means clear screen. Now if I run the code, see, only the message which is being printed in this compilation, this particular compilation has been printed. The previous ones are erased. So these are some of the editings that you need to keep in mind when you are working with Turbo C++. But you can of course use Turbo C++ wherever you are comfortable with. Most of the programmers use Turbo C++ because it is easily available. So let's go on and see if there is any other way, to write a program. So let's see. So let's see how to run the program in GNU GCC compiler. For that you need to open the internet. I'm opening the browser. So whenever you use GNU GCC, you need to fire up the browsers to get the GNU GCC online, and here you will write online Linux terminal. Okay, so in the first link, that is a tutorials point link, you will open it, and it will take a bit of time because the net is slow, the Wi-Fi is not reachable properly here, and is not reaching here properly. So this is the Linux or Unix terminal. Okay, now what was the first instruction? Let us tally and work because this is a bit tricky. You have to open a file in VI editor. Now how to open a file in VI editor? Now what is VI editor first of all? We have Notepad in Windows. We have Notepad++ in Windows. What are these? These are editors. You edit a text over here. Right. Similarly in Linux, we have VI editor and a modified version of VI which is also known as VIM. Alright, so we are using VI editor. We are not using VIM editor. So we will write VI first.c. First is the name of my program, .c is the extension, it is a C file, so .c. Alright, and VI means I am going to open it in VI editor. First is the name of the code, .c. Now why am I opening it in this manner? Because I am using command lines. This is the command mode. This is not graphical user interface. I am not using graphics here. I am using commands. I'm not clicking. Here mouse doesn't work. Okay, here mouse is just like a pointing device, nothing else. So once you press enter, you will enter into a thing like this. And what was the next instruction? You need to press I to get into insert mode, then you have to write the code. So you press I, see it turned into insert plus something else. Alright, and to write the code we have to first include the header file, so we include the header file, include stdio.h, no need for conio, int main void. So let us print another message over here. Let the message be printf. The message be hey there. This is one of the message. This is another message that we are going to print, and then we are going to return a value. So this is our code. Okay, in here, out here. So after writing the code, what was our next instruction? To press escape and then press :WQ. So we do the same thing. We press escape and then we press :WQ, And next what we do was, so you have exited, you have saved the file, and you have come out of the editor. So if you want to see that whether the code was saved or not, so you again open the file in vi editor. You see it is there. You again press escape :wq and you press enter. So next what you need to do, you need to press gcc space filename.c. so you will press gcc, file name is first with .c extension, and you press enter. The code has been compiled. Now see the difference. You have seen the compilation speed in case of code blocks, and here you see the compilation speed. You need to press this button .front/a.out. This is the instruction that you need to give in case you want to get the output of the code, and you press enter. Here is the message, hey there. Just took seconds to print the message. And if you are done, you have to press this message exit, and you will be disconnected from the server, and then you close it. So that's all we have in this section of this, and in this section. So let's get back to our slides. So we are done till here. So now we know how to compile codes in different compilers, which include code blocks, Turbo C++, and GNU GCC compilers. In case you have any problem, comment below, and I will try to clarify your doubts. Anyways, let's move on to the next section, the header files. As I said, that the first thing, that is a header file, will be discussed later on in this particular video. So here we are here with the header file definition. What does the definition say? The header file is a file with an extension .h. We have seen that the header files have an extension .h, which contains C function declaration and macro definitions to be shared between several source files. That is, there are some inbuilt functions. For example, the printf function, it has been built by the developers of the C, and it has been put in the stdio.h header file. Okay, and we are using it in different programs. We will use it in printing messages, we will use it in printing data, we will use it in printing characters, numbers, etc., etc. So we will do it over there. Alright, and there are two types of header files: the files that the programmer writes and the files that comes with your compiler. That is, the header files that comes with the compiler, we know that the developers have developed these header files, and another one is the files that programmers write. For example, C++ is just an above version of C, where the header files have been written by a programmer. The programmer's name is that Jarne Starstrup, that name which I can't pronounce. So he wrote that, and he developed it into a different programming language. So you can also do it in the same way. What you just need to do is you need to write the programs, you need to save the program with .h extension, and you need to keep the header files in the path of the compiler or the program. So next, these are the different header files that we have got in C and C++. So you can go through it, and they are in your books. Mainly we are going to use the math.h header file, the stdlib header file, the string.h, the c-type header file, and the stdio.h header file. And these header files are not used as such, but we might come across these header files at times. The final slide, and the most important slide to be a good programmer: what are the desirable characteristics that your code should have? The desirable characteristics include integrity, clarity, simplicity, efficiency, modularity, generality, and that's it. So let me explain each and every term to you. But before I explain, remember one thing, that these characteristics apply to programs that are written in any language, not just C. That means if you are a programmer, you have to keep these things in mind, these 6 characteristics in mind, irrespective of the language which you are using. Alright, so this is by far the most important slide that we have come across in this video. So the first one says integrity. What is integrity? Integrity refers to the accuracy of the calculation. It should be clear that all other program enhancements will be meaningless if the calculations are not carried out correctly. Thus, the integrity of the calculation is an absolute necessity in any program. The next part says clarity. Clarity refers to the overall readability of the program, with particular emphasis on its underlying logic. If a program is clearly written, it should be possible for another programmer to follow the program logic without undue effort. It should also be possible for the original author to follow his or her own program after being away from the program for an extended period of time. One of the objectives in design of C is the development of clear, readable programs through an orderly and disciplined approach to programming. A very simple example is, if I give you a program and if you are not able to decode it, the logic, you cannot decode the logic, it's no use. Alright, this problem is faced in industry every day because the programmers don't give proper clarity to their code. Clarity can be given to the code by allowing proper by putting a good deal of comments after every instruction, but we generally don't do it. But it is a good practice to keep a clarity in your code by any means. The third one says simplicity. Now the clarity and accuracy of a program are usually enhanced by keeping things as simple as possible, consistent with overall program objectives. In fact, it may be desirable to sacrifice a certain amount of computational efficiency in order to maintain a relatively simple, straightforward program structure. Efficiency, the fourth point, is concerned with execution speed and efficient memory utilization. There are generally important goals, though they should not be obtained at the expense of clarity or simplicity. Many complex programs require a trade-off between these characters. In such simulation, experience and common sense are key features. The fifth point is modularity. Many programs can be broken down into a series of identifiable subtasks. It is a good practice, or it is a good programming practice, to implement each of these subtasks as separate program modules. In C, such modules are written as functions. We have come across the term function in our second slide, isn't it? So it is a good, in C the modules are known as functions. We will know about functions in details in the following videos. So the use of a modular programming structure enhances the accuracy and clarity of a program, and it facilitates future program alterations. And the final and the sixth point, the last but not the least, generality. Usually we will want the program to be as general as possible within reasonable limits. For example, we may design a program to read in the values of certain key parameters rather than placing fixed values into the program. As a result, a considerable amount of generality can be obtained with very little additional programming effort. We'll understand the generality term when we will talk about dynamic programming later on in this course. So till now, I hope it was clear that you need to keep the program as general as possible, and you should not assume things from beforehand. You need to write a program for general purpose, right, for every situations that occurs while running that particular program. So this is it for this video. Hope you liked, and see you next time, and I hope you will work hard on C programming. So see you next time. Have a nice day, and please do subscribe my channel for further notifications of new videos. Thank you. Thank you everyone.